Welcome back to Algebra 1, Chapter 11, Section 8 in this book, which is the last section of Chapter 11, and then we have Chapter 12. And remember I told you that in public school, a lot of times if you finish 2/3 of the book, you're done for the year. So this is just the bonus stuff we're talking about now, the icing on the cupcake. But there are a few things that are important, which I'm going to point out to you, and some of this is really fun. So in this section and in the next chapter, I'll be telling you sort of what I want you to know and what I know. Okay? So what if you have a problem that looks like this? Before, what we were doing, they didn't have equals. But this is actually easier if it has an equals, because we can do something that I call clearing the fractions. We'll do it down here. But anyway, okay, so we have an equal sign and we have fractions on both sides. Do you remember that we learned a long time that if you have an equal sign and fractions on both sides, what do? Cross multiply and solve for x. And it might look fancy, but that's all we have to do, and it's really pretty easy. So we draw our cross to remind us what to do. 5 times 3 is 15. Bring down the equals. On this side we have x times x plus 2. We did the distributor property, so we have 15 equals x squared plus 2x. And if we minus this 15 over here, then we would get 0 equals that, and this could be factored then. What can we multiply to get 15 but add or subtract to get 2? Why, 3 and 5. The big one gets the middle sign. And what does the other one have to have the same sign as that? A negative. So our solutions are the opposite sign of these, 3 and negative 5. See, that wasn't so bad. But we can't cross multiply this one because of that plus sign. But what we can do is the thing I just mentioned called clearing the fractions. And it is this rule in math. You can do anything you want as long as you do it to both sides of the equals. And what I want to do is get rid of fractions, because deep in my heart I think I hate fractions. I'm not sure, but I think I do. So how I can get rid of the fractions is by doing the opposite. I have a divided by x and a divided by 3. What's the opposite of dividing by x and dividing by 3? Multiplying by 3 and x. And I can do it as long as what I do to one side, I do to the other. I do to the whole thing. Then it's legal in math. So what happens here? Here, I'm going to multiply 3x times this term. The x's cancel out because I have one in the numerator and one in the denominator. And I'm left with 3 times 2, which is 6. Isn't that prettier? Let's do this one. I'm going to multiply my 3x times 1/3. What happens to the 3's? They cancel out, and I'm left with x times 1. Bring down my equals. I'm going to multiply 3x times this. The x's cancel out, and I'm left with 3 times 4. So now, why is x not alone? It's got a plus 6 here. What's the opposite? Minus 6. What I do to one side, I do to the other. X is equal to 6. Wasn't that fun? I really like that. Okay, what in the world is all of this? It's actually the same thing. Okay, so here I have negative 4 over x minus 3 plus 1 minus 10 over x squared plus x minus 12. And that looked to me like it might have x minus 3 as a factor, so I factored it, and it does. So I'm going to get rid of that and have this as my denominator. Now, I want to get rid of fractions. I want to clear fractions. I have an equals. I can do it. All I have to do is multiply it on both sides toward elements of the denominator. I have in the denominator an x minus 3, nothing there, and an x plus 4. So I'm going to multiply it times the whole thing. So first I'll multiply it times this term, and the x plus 3's cancel out, and I'm left with 4 times x plus 4. Negative 4, I didn't say it. Okay, now this one, 1, there's nothing to cancel out, so all that I'm going to have here is if you multiply 1 times anything, you get that thing. And then here with the 10, this is going to cancel out. This cancels out, and that cancels out, and all I'm left with is minus 10. Now, is that any better? Yes, it is. Because now I can do the distributive property here and get negative 4x and minus 16. I can multiply this back out to this and put it down here. I don't have to multiply it because I know what it is. And there's my minus 10. Now all I have to do is gather up my terms. Yay! We're going to dance and sing and gather them up. I start with x squared. There it is. Mark it out. Now the x's, negative 4x plus x is minus 3x. Mark them out. Bare numbers, minus 16, minus 12, and this minus 10, which needs to go over here and be a plus 10 to both sides. That makes sense? So we have 0 over here. Well, that's negative 28 plus 10 is negative 18 equals 0. I can factor this into x minus 6 and x plus 3. So my solutions are 6 and negative 3. Now, do I expect you to be able to do this? No. You're Algebra 1. Will I expect that in Algebra 2? Yes. But will I expect you to be able to do this? Yes. Make sure you can do this one and this one. But hopefully that one kind of makes sense to you. The other thing is we're going to talk about graphing. If you graph something with the x in the denominator, you get a shape called a hyperbola. Your book teaches you how to graph this and all this Algebra 2 stuff. I don't care if you know that. What I want you to be able to do is do it on your calculator. I want you to be able to go to y equals and very carefully type in 1 divided by x. If you use the divided sign, you need to put it in parentheses or use alpha y equals so you can type it in as a fraction plus 2, or do that one, and you will get this graph of this shape called a hyperbola. Once you get the graph on your calculator, hit the trace button, and you can say, well, if x is 0, it'll say undefined. So, because remember, it's going toward asymptotes. I can't write ass on the board, but asymptotes is right here, meaning it gets closer and closer to the line without touching it. So it's undefined at 0. So then I say, well, what if x is 1? It'll tell me y is 3. And I put a dot there. What about if x is 2? It tells me it's 2.5. Y is 2.5, it's right there. Then I say, well, what if x is negative 1? Y is 1. What if x is negative 2? It's 1.5. And then once you get some points, you draw your lines. I want you to be able to work backwards from your calculator to looking at the graph, to getting an xy, to drawing a few points, and drawing it. Okay? So go through your book. For each of the ones in your book, I want you to make sure you can do it on your calculator. This is going to be 100% calculator until you're in Algebra 2. Alright? And that's fun. Making fancy graphs on your calculator, right? Okay? Come back for Chapter 12. Math is great.